Here's a little homework help from section or lesson 4.8. This is page 290, and I've chosen two problems, one of each type that you had to do for the homework. And from this type of problem, number 14, you were told to evaluate a function using two different inputs, but instead of doing direct substitution, which is what we've done in the past, we're going to do synthetic substitution. And so for f of -5, we're going to put -5 in the house, and we're going to set up synthetic division, really, the synthetic division process. So I'll start with a coefficient 1. There is no x to the fifth, so I need to plug in a 0. Then -4. There is no x to the third, so another 0. +3. There is no x to the first, so another 0. And then -10. Okay, leave a space. We're going to draw a line. And now we're going to begin the synthetic division process. We'll bring down this first number below the line. Then multiply 1 times -5. And we add. You always add with synthetic division. Multiply -5 times -5. That's 25. And then add. That's 21. Multiply, that's -105, and then add, multiply, that's 525, add, 528, multiply again, that's -2640, add, multiply again, -2640 times -5, that's 13,200, and then when you add, you have 13,190. So the answer to f of -5 is 13,190. Alright, and now we're going to do the same thing for f of 2. So we'll put 2 in the house, use these same coefficients and constant, and we'll go through the process. So bring down the 1, multiply, add, multiply, add, 0 times 2 is 0, add, 0 times 2 again, 0, 3 plus 0 is 3, 3 times 2 is 6, add, 6 times 2 is 12, and we add. So the answer for the part f of 2 is 2. So that's your complete answer for number 14. And now let's take a look at another problem from the other section, and this is number 26. And in this section, you were given two factors, and basically we have to come up with the other two. But we're going to use synthetic division in order to do this as well. So this time I'm going to put +2 in the house, and I'm going to set up the synthetic division process. So 4, -16, +7, 36, -36. We didn't skip over any exponents. 4, 3, 2, 1, constant. So no need to plug in a 0. So let's draw the line, bring down our first number, and multiply. 4 times 2 is 8, and then you add. Multiply again, -16, and add. -18, add. 36, and add. So we already knew that x minus 2 had to be a factor. We were told it's a factor. Now we've proven it because we got a 0 remainder. So let's take this result, this cubic, 4x cubed minus 8x squared minus 9x plus 18, and see if it can be factored. So at this point, you really have two options here. If you notice, you could apply the factoring by grouping that we've learned because there's 4 terms here. You could do factoring by grouping and you'll get the same answer. I think I'll just go ahead. So I'm going to go ahead and show you how you could have arrived at the correct answer in really two different ways. So let me show you first of all factoring by grouping. It's a good little review of what we've done recently. So in this first group of two, do you notice that we can factor out 4x squared? And when we do, we would get x minus 2. And then in this next group of two, I'm going to bring down minus, and 9 goes into both of these, and you're left with x minus 2. Okay, so my parentheses match. I already know that x minus 2 is a factor. Do you notice how I'm told that x minus 2 twice is a factor? So we've already proven x minus 2 is a factor once because we used regular 2 and we got a remainder of 0. Well, now we've proven that x minus 2 is a factor again, because remember how we write the answer to factoring by grouping. X minus 2 is like a GCF, and then the other part, the terms that are not in the parentheses, we will write as another factor. Okay, so up to this point, we've shown that x minus 2 times itself, or used twice, 2 different times as factors. So when we factor this other part, we'll come up with the other 2 factors. Remember, there should be a total of 4. So hopefully you recognize that 4x squared minus 9 is the difference between 2 perfect squares. So when we factor this out, we get 2x plus 3, the square roots, and 2x minus 3. So the final answer here, the other 2 factors to go along with x minus 2 times x minus 2, we will include 2x plus 3 and 2x minus 3. So that's the answer to number 26. Let me just show you how you could have just used synthetic division again. So this is an option. So I'm just going to erase this. Hopefully you already have this down. You may have already worked through this problem and you're thinking, well, I didn't do factoring by grouping, and that's okay. You could just go ahead and take this result, use 2 again in the house, and now we're going to use 4, negative 8, negative 9, 18, and go through synthetic division. Bring down the 4. 4 times 2 is 8. 0. 0 times 2, negative 9. Negative 18, 0. So you can kind of see how we're going to end up with the same result. Let's take these numbers. This is a constant. There is no linear term. This is quadratic. Remember, it should always be 1 degree less. So we're going to be taking 4x squared minus 9 and factoring it. And that's what we had earlier. When we factor it, we get 2x plus 3 times 2x minus 3. So it's 2 different ways, 2 different approaches to come up with the same answer. Just wanted to show you both just in case you weren't sure if you did the right thing in cases like this, and this happens quite often, to be honest with you. You can either get to the final answer by factoring or by running through synthetic division a second time and then factoring. So anyway, that is your final answer for number 26. I hope that helps you out, and let me know if I can help.